So the agenda for this morning, Victoria Friedenson, who I could have sworn was behind me but has suddenly ninjaed herself over there, is going to give you a very brief discussion on precursors. Then we've got just some slides to promote discussion on the topics broadly under the header of lessons learned and path forward. Some talk from the Evolvable Mars campaign folks on reference exploration zones. We're going to talk about prototype exploration zones and then a final discussion for the morning. Victoria.
Thanks, Ben and Rick. This has been a great week. I can't recall the last time I had this much fun. So I'm Victoria Friedenson in NASA headquarters in Human Exploration and Operations, and I'm the Robotic Precursor Mission Lead for Human Exploration. So the term Precursor Mission has a great deal of baggage for us. It's very, very important. So when you say precursor, okay, I think as I was listening to you all, and this is just food for thought for the next time, or as you generate your comments, okay, so there's a couple of different kinds. So for human exploration, a precursor mission answers the very important question, what do we need to know before we go? What is the data we need to effectively design the systems and the technologies that will get the crew there, get them back, and allow them to work safely and productively wherever, at whatever destination it is. Okay, so that's a sort of a human exploration-y precursor. As I was hearing you yesterday, there's also the concept of a science precursor, which might be something even as simple as validating that this EZ is the way coolest science EZ ever, and let's all go there, okay? So as you think about suggesting an interim mission, an additional data gathering mission, think about the word precursor and figure out whether it applies to productivity and safety for humans, or whether it is getting you that next step in data to allow you to move forward in a final decision. Thank you, Ben.
Thank you. Okay, so the first thing we wanted to get feedback on is the idea, just sort of validation on the concept of an exploration zone. This is something that was, well, it was new to us, so I assume it was new to you too. But basically this idea that when we go to Mars with humans, you know, we are exploring a region and we want that region to have multiple areas of scientific interest as well as resources to use and a safe habitation site and landing site. My only very minor comment is I saw several of you using HZ for habitation zone. I saw that and I saw hazard. So let's stick with habitation site. Also, HS could stand for high school, so people would go, oh, that's good. So I must admit, I only have this slide on this because I've been really pleased by what I've seen, and I think just from the quality of the talks from all of you that I think it does appear to work as a concept. But that said, if people have any thoughts on things you would like, modifications or even just validation, I'd like to just open it up to a few minutes if there are any comments. Again, please wait for the mic so that the Ustream folks can hear, and start with your name and who employs you. Steve, do we have a transcript?
All right, it's on. All right, Mike Siebert from JPL. With the exploration zones, one thing I did notice on a few presentations is, and speaking as an engineer, so I interpreted this as a requirement, was we want to be able to go in this concept 100 kilometers from the habitation site. I did notice a few exploration zones, and I even considered this myself before rereading the supplemental material, and put the habitation site at locations that were not the center of a 200-kilometer radius circle. So one thing to consider is, do we have flexibility inside the EZ for placement of the habitation site, although it may limit the traversability out to the far reaches, or is it a requirement to actually say this is what's within this radius from where your habitat is?
No, that's a good point. I did notice also that sometimes the habitation site wasn't in the middle. In principle, it should be, because the idea is you are roving from that site. Right now, we are carrying a 100-kilometer capability. So theoretically, if you had a science ROI that was more than 100 kilometers, it's like, can't do it. But in reality, we're far enough away from doing this that one of the interesting things I think to come out is, given the idea of going with multiple crews, does 100 kilometers give you enough things to do? I suspect it does. We're going to talk about the operations and how long the crews, how long is it going to take to do the field work, etc. once you're there. But one of the things to get feedback on is actually we don't even need 100. We could do 5 crews in 30 kilometers. So no, it shouldn't be like a here be dragons, you can't go. Also, there's always the potential that you might do, once you're there, human telerobotics to expand your reach beyond where the crew... With the crew reach, it's going to be safety. How far they go is going to be a function of probably how many pressurized rovers, their capability, reliability, etc. So it was just, we felt a good... Even going to 100 kilometers was very different than what I've seen from the previous sort of robotic landing site studies. It clearly, to me, has got everyone thinking a bit differently, which was good.
Fred Califf, JPL. I just want to follow up on that a little bit. One of the things I did in the map in my presentation, although I didn't specifically point it out, was actual drive distances. Just because you have a 100-kilometer radius doesn't mean that you drive a straight line in any direction. You hit 100 kilometers. There are many cases where I saw that there were ROIs I specified that were actually, within the 100-kilometer radius, but they would have taken 150 kilometers to drive. So there has to be some practicality put into our presentation. I know this is, this is first round, big tent, collect everyone, but I think the next round we really have to think about, just because it looks flat doesn't mean it is flat, and there are certainly parts in some exploration zones that were not flat. We're not climbing up the cliff face to get onto the top of a mesa without extreme measures, and I don't think anyone's thinking that we're going to fly up there or whatever the case may be. So I think we definitely have to think about what the topography is, what the actual drive distances are from a habitability site, and that might mean that we have to push it so that if 100-kilometer drive range is what we're really talking about, that might move a landing place, and then maybe that will be viable, maybe it won't be.
So a couple of things. As I mentioned on the first day, 100 kilometers is something for all of you to get a sense of how big of space to think about. It's not a hard limit, as he said, that here be dragons, don't go out there. It's not that. And we understand that 100 kilometers is not the odometer reading. From the tests that we've done in the desert, the linear distance, just a rule of thumb is multiplied by 2 because you're going back and forth, up and down. So out and back, factor of 2, we're talking 400 kilometers on the odometer. The kinds of rovers we're talking about, with the power supplies that we're talking about, and the kind of the time we're allowing to do those kinds of things, we think we can do that. That's where 100 kilometers came from. Now, it doesn't mean that if you're 110 kilometers away, you can't go there. And it doesn't mean that if you got a lot of really bad terrain between where you start and where you end up, that you'll reach 100 kilometers. It's a way to set up your expectations about what can I reasonably think I can get to. And there's another step that has to happen, is that when we start looking at these in detail, we'll start looking at what is the path that I need to get there. And if I have to go all the way up here and then all the way back down here, you're probably not going to be able to do that. So the 100 kilometers, it's not a hard limit. It's a way to scope the size of the area that we think we can get to. And what we wanted to get out of this workshop was a sense from all of you, if I had that much space to work with, what could I do with it? And I think we got a good sense for that, and that's going to be helpful. Now, one of the things that we will do, we on the HEO side, the EMC side, will start taking some of these, and we'll talk about this in a little bit, and start looking at what can we do with that. Can we expect our rovers to get that far or not? And we also have the opportunity to say, this 100-kilometer-ish kind of range, the 400 kilometers on the odometer, maybe that doesn't work, and we need to do something different, and we can go back and start changing those things. So just understand that that's what it's there for. It's not a hard limit. It's not a requirement that we are going to meet or we're obligated to meet. It's what we think we could do now, and we want to see what kind of reaction we get when we start looking at real sites.
Yep.
So I just wanted to make a general statement in support of the exploration zone concept from a scientific point of view, because I really like the idea of going to a fascinating, diverse place on Mars and developing a deep understanding of it. I mean, this is the way you find out about complicated and deep geologic time kind of processes on Earth. So I really like the idea of doing that somewhere on Mars. So just thumbs up from a scientific point of view.
Jim? I got a big mouse. No, you don't. You can't reach across the internet even with a big mouse. I would also like to say that Here Be Dragons would be very interesting from an astrobiology sense.
Okay, Jim Rice, Planetary Science Institute. I know this is early stages, but safety, risk reduction. When the crews go out, are the rovers following in tandem for safety, in case one breaks down? If that's the case, that's going to kind of limit your area of exploration, because I can see a scenario, one crew goes out, another one goes 180 degrees away, and one of them breaks down. Are you going to get there in time? Highly doubtful.
I mean, I think that's a level of detail, Jim, we're not going into in mission ops at this time. That will obviously be considered when we go for real. We're not going to let people go off, just like with Apollo, unless there's a solid scenario for getting them back.
Okay. I know it's early, but just curious thinking about things,
Maybe we can cover that when you talk about your reference. Yeah. Oh, I can't. Sorry, you're blinding.
I'm in the dark. Yeah.
Okay.
Don Parker. If you remember yesterday on my slideshow, I kind of addressed that. I like the idea, but I kind of had more than a 5-mission roadmap. I had like a 100-year roadmap. Once you have a firm establishment of a large infrastructure, then you would have the ability to actually make new circles, basically exploration zones, by taking camping type supplies, base fuel type infrastructure to another location and expanding to a second place. And that also gives you redundancy on the surface. So you could actually expand your entire concept of the region by making new exploration zones, by just putting small caches of emergency reserve supplies at equal distances on the other side of your original zone.
Yep. One more, then we move. Yep.
I want to go back to the question you asked originally, which was what precursor missions are you interested in? And so what I'm interested in is to have a replacement for MRO with whatever sun of Highrise is and whatever other spectral bands we would like to have that we don't have with CRISM. And the second thing that goes with that is an additional, don't know whether you can do on one asset the amount of comm that we would need to increase the frequency with which we could open up comm windows between Mars and Earth. But that would be both a safety and a science issue that would make life much more efficient.
Okay, thank you. Okay, next I want to come to one of the topics which was the original rationale for having the workshop, which is what would be the most useful data that MRO could acquire while it's still healthy in order to help HEO and all of us with future planning of the human missions. And we have a suggestion here that's been worked with the MRO project, and that's that each exploration zone that's been proposed can choose up to 3 targets for future MRO imaging. These requests will be tagged as HLS2 requests within the MRO system, so we can filter and see what you're asking for. You'll prioritize your 3 choices, so you'll have a first, second, and third priority. Essentially, the data will be collected on an as-possible basis. And talking to the MRO folks, realistically, you will probably get your top choice imaged within 12 months. And I don't know whether Rich or Alfred want to correct me or add anything else. Yeah, let me get Mike. Ready.
So what you'll find is that how quickly you get your image will vary widely. It's not because we like you better or less. It depends on where you are on Mars. We have, 12.8 orbits a day. Some orbits are really highly contested. That the one that goes over MSL and InSight, don't put your easy there. Okay, Valles Marineris. There's so many good targets. It's heavily contested. Dusty regions like Tharsis. If you have got an exploration zone in there, you may get all 3 of your images quite quickly, so it's high latitudes, northern latitudes will do better because we're in late northern spring now, and we're at high data rate when we're at northern summer. So you'll see a lot of variability. It's not because we like any site better than another. It's just geometry and seasons and so forth. Okay. Yeah. Well. Yeah,
that can be open. This is why this has been thrown out as a suggestion.
Okay, so a lot of you will want stereo, and then you get 2 images. But It's going to take longer to get it probably because we limit the number of stereo ones because if we have too many in their backlog, then we can't complete it quickly when the lighting's good and you have to wait a Mars year to complete the stereo. So we limit the number of stereo ones. So there, again, if you want stereo, you can ask for it if you really need it, but you'll get your image quicker if you don't ask for stereo. So that's the trade-off there.
The question was, what is the target here? It's not the exploration zone. It's an image. It's a request for either Highrise or CRISM. If it's shroud data that you need, we're going to have to think about a different mechanism than this to get that in. We were thinking that for most of those radar requests, we're really dependent upon that next orbiter bringing a new capability for confirming ground ice extent and such. So again, remember, the target isn't the whole exploration zone. You won't get that coverage. Take a look at the coverage maps that we had there.
Regarding Odyssey Themis, you can also consider that as a request vehicle if for some reason there isn't the appropriate Themis coverage, either time of day or visible mode, etc. So I know it says MRO targeting up there, but Odyssey Themis is also available to support this.
Also, if we're using HighWish, I believe that's the suggestion here, that's designed for Highrise. You can also request CRISM. Be sure and say very clearly CRISM is your primary interest, and you probably want a Highrise rider, but we can do it that way. I don't think we can really handle Shroud or anything else that way.
That's why I said we'll have to look at a different pathway for that. So with HighWish, we'll give you instructions, detailed, how to enter targets in if you think this is the right approach. Because you notice what we're not doing here is we're not saying, okay, we're going to pick those independent of your input. We're giving you a chance to put in what your priorities are. And remember, if you want stereo, for instance, that's going to take up another of those slots. So we're going to try to make progress. We know that some of these sites have a lot of information because they're on other candidate landing sites, but the exploration zone may give you new targets that wouldn't be considered for a place like Jezero Crater, for instance. And so all those things are there.
Thank you. Comments?
Frank Hale of JPL. Another good image set would be CTX stereo. You have 95% coverage mono, but a few CTX stereo images across an exploration zone will give you kind of a first order idea of topography and traversability. So that, I don't know how CTX gets requested. I don't think there's ever a formal mechanism, but that could be very useful at many of the sites.
CTX is a facility instrument, and if you're taking a CRISM or a Highrise, you will get a CTX image. I want to repeat, there's a lot of data out there, including 20% CTX stereo out there. So take a look at that, because we noticed in some of the presentations you weren't using the highest resolution stuff available. It's out there. So take a look and save us some trouble of, okay, we already got that one.
I have.
Okay.
Question at the back.
If you request Highrise stereo, you'll get CTX stereo along with it, but it's probably their standard small image. If you want a bigger CTX stereo, say so. And hope for the best.
Perhaps one more at the back, and then we'll move on. Yeah.
For all of you ISRU people, Paul and Angel and Leslie and so forth, who are completely unfamiliar with these processes, I strongly encourage you to team up with some of the scientists who sort of live and breathe this kind of thing and have the connections to enter these kinds of targets. Otherwise, we'll try to help you as best we can.
And that actually led to that was kind of right along the lines of my question, Kendall Lynch, Colorado School of Mines. I was wondering if we could get some focused direction for making sure that we, this is great, but some more focused, detailed direction, I'm assuming in an email or something like that, as to how to, put in the target requests, how to tag them specifically, how to, kind of a good checkoff list to make sure that we get it targeted so that they know that we're the human landing site, we're evaluation and all that. For those of us, especially who do not have experience doing this on a regular basis.
We'll send out instructions.
Excellent.
Okay. So next thing I'd like to discuss is dialogue. To me, this is one of the most important results of this workshop, particularly promoting dialogue between the science, ISRU, and mining communities. There's been several occasions where people in the audience with mining experience have made what I would call polite statements about realities of extractions of resources. And I think that's really useful. I think it's got the scientist folks thinking differently. And I'd really value a discussion on going forward how we can continue to facilitate this dialogue between those communities. One thought that's been suggested is the ICEMAG, the ICEMAG, which remind me.
ISRU, Civil Engineering, Manufacturing, Analysis.
Right, would be to have what she said. Would be to set up something like this with the key people to work on how we do this dialogue. Another discussion I've heard is, do we want to have specialized resource workshops? To me, one of the big unknowns that really is what we've heard over the last 2.5 days is what really is a resource. Both from we don't quite know how much water there is in a particular thing that we think has some water, but there's also how difficult, how much power would it take to extract the water? What really is the best resource? And maybe what is the best resource is a function of location, a function of latitude. So the idea I heard discussed was like, do you have very focused small workshops, say as focused as, say, polyhydrated silicates, and you get the right people in the room and they discuss what's the current level of knowledge, what do we need to know in order to really understand if it's a resource, and how hard is that resource to use? So we sort of start to, going forward, work out how we narrow down what are the resources that we would want to use. And related to dialogue, well, actually, let's stop there and see if there's any comments on how we should go forward promoting dialogue on resources. There must be.
Yeah, so one suggestion might be to see if we can approach some of the bigger conferences, well, LPSE or something like that, and add a session that is dedicated to this kind of thing. That's a great way because you'll have a lot of people already.
You could, but the one issue with that is, again, you're not going to get, say, the mining community going. I'm thinking about focus workshops where we invite at least some of the key people are invited. But I agree that's something that we would do as well.
I mean, I think you might be able to get more to LPSE.
A waving microphone at the back.
Yes, well, to address your question, this is Leslie Gertz at Missouri University of Science and Technology. Mining geological engineer. There are meetings, there are conferences. There's the Earth and Space Conference next April in Orlando. Rob Mueller here is actually the chair of that conference, and it focuses largely on ISRU and civil engineering in space. In fact, we have a short course associated with that conference that is titled Space Mining and Planetary Surface Construction. We had one last year, the first time, and we filled up. I think we're going to have to make it larger this time. But there's also the Society for Mining, Metallurgy, and Exploration, which is the United States and International Mining and Exploration and Processing professional society. There's a Canadian Institute of Mining and Metallurgy. There is, as you said, the American Society of Civil Engineers, which is what Earth and Space is associated with. There are a couple of conferences, the AIAA sponsors that have sessions on ISRU. So there are a number of venues, and probably others that would work as well, that we should link up with. There's a Space Resources Roundtable held every year, and the Planetary and Terrestrial Mining Sciences Symposium. So they often meet together. So yeah, lots of places.
Yeah.
Also, there's an off-Earth mining forum in Australia, University of New South Wales, starting 4th of November, next week.
Rob?
Rob Mueller, NASA Kennedy Space Center. As far as the new acronym ICEMAG goes, I'd just like to say we're looking for volunteers that would like to be involved in this. Several people approached me this week saying they would like to get involved in that, and now is the time to speak up. We need to form a group that is not necessarily the usual suspects, get some fresh blood involved, and so now is the time to speak up if you'd like to get involved with ICEMAG.
On the subject of, moving back to the subject of workshops, one thing that we should consider, given travel restrictions, is maybe a good mechanism for doing small, especially like learning and informative workshops, is doing some virtual workshops, where somebody who's a subject matter expert can get on and kind of teach or do an overview of a specific, like an ISRU kind of introduction. You can do that virtually pretty easily, and then that way that's opened up to the whole community really easily. People can dial into Adobe Connect or something like that, kind of get an overview, get an understanding, have some question and dialogue, and kind of be brought up to date on the basics. And then that allows us to do some more high-level advanced in-person workshops, either adjacent to a meeting or independent where people have to travel. But I think we should really think about trying to do as much virtually to kind of help people learn as we can.
Okay, great.
Andrew Wheeler, exploration geologist, consultants. This is exactly the reason why we're here, to talk to Rob and to other people. We don't have the contacts to all the research, and we want to be involved in that, so we'll line up for IceMag if we can.
Okay, two more. One at the back there, and then Silly.
Yeah, Laura Kerber, JPL. I was thinking, so for the specialized workshops, and we're really interested in engaging the ISRU community, and it also seemed like through this week we've heard a little bit about like engineering things, like this actuator, it'd be hard to work in a cold environment, or that's something as a scientist I don't think I'm that familiar with that set of challenges, and so even if there was a meeting that those sorts of people had that we could be invited to, or that we could have a little special session alongside whatever they're doing. So we had a kind of an opportunity to immerse ourselves in their world and sort of see why they come up with the restrictions they come up with and where that all comes from. I think that could be helpful.
Taishik Lee from Korea. When you visited Korea with Jason Cruson, we were talking about the dirty vacuum chamber, and the cubic size is 50 cubic meters, and then the environment like the Mars and Moon. So for the international collaboration, I'd like to make some committee or the workshop for the Mars environment vacuum chamber.
Okay, great. Thank you. Last one.
Jake Bleacher, Goddard Space Flight Center. Just following up on what several people down here, I heard Leslie talking about the different meetings that are going on. It's actually a simple problem of awareness. And I think this would be something that could be handed off to the IceMag, but in the short term, if we can just try to maybe make a calendar or something that we can get these things on there so that all the communities, the planetary protection, the ISRU, the scientists can actually see when they're on, because if the meeting's happening in your town and you're not aware of it until it's already done, that's no good. But if it's there, you could conceivably go fairly easily. So I think it's just we just need to get the seeds going, and just being aware that those meetings are going on is an easy first step, I think.
Yeah, and I would say that we also want to make sure these meetings are truly integrated. In other words, it's not just people haphazardly being there. In other words, we target to make sure the right constituencies are there as well. And so the intention, I think, here is just to get a dialogue going on what's needed, obviously specialized things, but we really want to systematically say we need reps from this group, and this group, so that we really get all the smarts at the table and do it right. Really, largely, I think we've done that with this meeting. So anyway, we probably missed some people, but the intention was there. So thank you.
Just one other comment, maybe more for Jim Green, actually. I'm not sure, but these sorts of meetings are really fun to attend. But for the most part, if we were to sort of approach it in a way that's not driven by science, for a lot of people that can be hard to use their funding for that. So I wonder if studies that relate to ISRU would fall under any of the existing research programs, or if there would be some maybe longer term development of a new program that would address that.
So indeed, it's a workshop like this that really shows us where the gaps are, and once we know where the gaps are, then it's a cooperative effort between HEO and Planetary Science Division to determine how we're going to fill those and what are the mechanisms. And we recognize that we need to look forward to do some important targeted investments. And so, as I mentioned, we're going to continue that discussion. We have a great relationship with HEO. We're involved in a couple things where we jointly fund things that are working well for us. And I think that bodes well, because I think that kind of activity is only going to increase. And so that gives everybody additional opportunities. That's our plan.
Thanks. Okay. Rick, if you want to stand up up to you. It's a big discussion. So we got some sort of lessons learned. What analysis, just to promote, what analysis need to be done to improve our understanding of the EZs, by the time we get to the next workshop? And as was mentioned earlier, don't forget the current data with your analyses. You don't necessarily always need more data. One thing I've heard from multiple people is it would be useful to define a standard nomenclature, almost to have a glossary that everyone uses. I've already touched upon realistic appraisal of resources. Something else that's come up with even again this morning is, do we want, at what point does it merit doing, for example, a trafficability analysis between the habitation site and ROIs? Maybe that's further down the road, maybe that's one of the next things to do. So I'd like to open it up to discussions on, as part of a path forward discussion, what we want to do next.
David Kring, LPI. And I want to actually come at this with a different perspective. I've worked with both SMD and HUMD on the lunar equivalent of what you're doing here today. And when we were trying to find landing sites for humans on the moon recently, we started with a map like you have there of everybody's favorite landing sites, but then stepped back. We had a set of criteria for what would define a good landing site, much like you have in the ROIs. You have things that are thresholds and qualifying. And what we did with the moon was we took each of those identifiers and asked a more general question: can we identify everywhere on the moon, or in this case Mars, where that can be addressed? And you start generating for each one of your bullets a global map. And then you stack the maps and you find exploration zones that you may not even have considered before that are particularly rich. In the case of the moon, the top two candidates for crew weren't on our map that looked like that. It was a very instructive process. That's the type of thing that the LPI did with the JSC for the moon. It's the type of thing LPI has done in the past, and we could help with that type of thing.
Okay.
Yep. All right, so Mike Siebert, JPL, putting on my flight director hat for the Opportunity rover, things that need to be fed in, I think, very early on are power, surface insulation. So your latitude, you're going to have a latitude dependency. You can fix that partially by pointing arrays, but you're going to have atmospheric opacity issues at different parts of the planet, and those will vary seasonally, and that may rule out, I know we're looking at nuclear power, but there is going to be some solar components to this, especially for long-range remote robotic ops. So that needs to be factored in. Thermal, I did see one presentation that mentioned the annual average temperature of the site. That's going to be key for mobility. You can spend a lot of energy in the winter trying to heat your mobility system, and if the site is just too cold for most of the year, you now have a field station where you can't explore from the HEP. And finally, I will throw the plug in for the trafficability analysis. If we're landing in a tight, flat crater with a flat bottom at the dead center of an EZ and it's got steep walls or maybe just one channel out, it's really going to limit your trafficability. So I think those, and a lot of that can be all done from orbital data. So I think that should feed in early to potentially rule out non-practical sites from an engineering standpoint. They may be great for science, but if we can't do anything there, we can't get the science.
Okay.
Austin Nicholas, JPL. Kind of to follow up what Mike was just saying, I think that considering the total productivity possible at a site involving engineering constraints, or the engineering realities, is really something that I felt has not really been considered fully in this workshop. It's not to say that a high latitude site should be automatically ruled out, but the realities of a high latitude site should be considered in that you may be doing less traversing, less you may be having to spend more energy on just keeping everyone warm, sort of thing, than you would at a lower latitude site. And maybe that's worth it for the science, but I just don't think that that's been really considered yet, and that's something I'd like to see more of going forward.
Paul, did you have one?
No, I was just going to second what I said before. I think this is a conversation. I don't think we should be stepping up to start ruling things out just yet. There's a lot of fluidity in engineering designs and mass that can be added. So we've added some criteria. We're working with criteria and assumptions based on the kind of stuff you guys are talking about. But I think as we go forward, I think this conversation will continue. So it's all good stuff.
I forgot to say who I was before. This is Pan Conrad, and my employer is NASA. And what I wanted to do was ask you a question. I found myself drifting off into designing a design reference mission and a requirements reference mission for a site that caught my attention just as I was doodling. And the question is it too early to do that? Because I think that would help inform us about some things like trafficability, thermal management, and so forth. What do you think?
Well, you're going to get a presentation in a minute on the sort of the level of work that goes into that, and maybe we'll come back to your question. And the idea of the reference site is also it brackets the engineering constraints. So if you can do the reference site, you can do other places without necessarily having to repeat all the analyses. So I'd like to come back. It's a good point. I'd like to come back to that after the reference site discussion. Yep.
Just a quick comment on the realistic appraisal of resources, kind of go along with the nomenclature problem that we have, perhaps also a common appraisal of the resources so we're able to better compare apples to apples versus one person using one method for determining a particular resource and another person using a different method, and you're not able to really compare the two because it's different data.
Okay.
David Wilson from NASA Ames. If you've got a lot of people on Mars will be spending a lot of their time doing maintenance and looking after the habitat, just as people do on the space station. And if you've got a small crew, you may not have a lot of time available to travel long distances and investigate sites. But if you've got a large crew, you will have more time to travel long distances and investigate many different places. And I think the number of people or the size of the crew may in fact play a big role in what sites you choose. There may be some very good places very near the hab. If you've got a rich site, that's good for a small crew, but if you have to travel long distances, you may not have the time to do that when you're on the surface.
There was another.
So I just wanted to bring up another kind of community that I think we should be including. Oh, Julie Mitchell, Arizona State University and JSC. So the life support community and the technology development community is, they're looking at next generation technologies for keeping people alive on Mars and for next generation vehicles. And I think they should be here. I think a lot of the information that we've been talking about is really relevant to the work they're trying to do, and it can actually help to guide the efforts that they're taking, because they're making a lot of assumptions on what the needs are going to be for future missions. And so I think, I just want to make a statement that that's another group we should try to include here.
Okay.
Leslie Gertz again. I wanted to touch on the need for a standard nomenclature, and I wanted to point out something that's been touched on before. What's the definition of dust? So I've looked up 5 different geotechnical soil classifications. And generally, let's see, sand is less than 2 millimeters across and greater than, anything from 0.02 to 0.07 millimeters. And we've got smaller than that, we've got larger than that. We need to know those sizes, because when we're separating ore from waste material, we need to get it to the right size so that every particle is mostly ore and every particle is mostly ore or mostly waste. And then we can do the separation. And that particle size is generally quite a bit smaller than the average grain size for the ore. And so we need to know those to a very high precision compared to what I've been inferring from the discussions here today. So just some numbers to chew on that. Look up geotechnical soil size classifications and see where we're coming from, and can the instruments that are up there now distinguish those? And if not, can any instruments that fly do that? And that's what I think we need to look at.
Okay, thank you. Actually, one at the back first, then you. Oh, so you have a comment on that? Okay.
So that's actually something, I'm Robin Ferguson, USGS. That's something that's been bothering me a lot as well. So I do a lot of work in the thermophysics realm, which is where we get these numbers for particle sizes and things like that. So from a planetary perspective, most people, I think, in this room think of dust as thermal inertia less than 120 units, because that's what's been designated by the rover trafficability experts as that's the stuff that we can't drive on very safely. That's actually a particle size of like 80, it's much, much bigger than what you're thinking of dust. It's more in the 80 micron range, not what you consider dust. All of our atmospheric science friends, though, think dust is like 5 microns. They're thinking atmospheric dust and things like that. And it is a really important question because all of us are coming from different perspectives when we start talking about dust. And mind you, neither of these definitions are what an actual geologist thinks of when they think of dust. So, I mean, that's a question I think is a really, really good point, that all of these definitions are valid depending on the community that you're in.
Okay.
And to address the question of how do we know. So when we interpret particle sizes from thermal inertia, we're actually still using laboratory work from the 1990s because it's really, really difficult to do good laboratory work for this kind of stuff in vacuum chambers, and that's absolutely what you need. This isn't a spectroscopy study where spectra doesn't change at different pressures. What we're talking about with conductivity is hugely dependent on different pressures, so I would highly recommend anybody that can more laboratory work to understand mixtures of particle sizes and what the conductivity, thus the thermal inertia, would be of those types of mixtures and surfaces that are more realistic for Mars are really, really needed to begin to address these kinds of questions with the robustness we need to.
Okay, thank you.
Jake Bleacher, Goddard Space Flight Center. I want to come back to the issue of making sure the communities are communicating, and Leslie was really touched on this there, but if we go back to Mike Wargo's strategic knowledge gaps, several people that I've worked with in this room noticed this issue that we identified the knowledge gaps, and those documents were put together, but then those documents got handed off to a different community or a different group of people who weren't familiar with the community. And the issue actually became, well, who knows the knowledge? Where is the knowledge? So we're aware of what we don't know, and somebody wrote a document saying that people know this stuff, but who are the people and who do we talk to? Because if you're in a different community, you don't know where to go get that information. So I think moving forward, and we're looking at maybe what are the next steps, the integration of these communities is extremely important, and keeping track of where that information is. So Mike was talking about making sure we preserve some of the information from the operations that we know on Mars, but some of the other communities might not be aware of where those reports are written. And especially if they're in the gray literature internal to NASA, a lot of the folks we're talking to here are not internal to NASA. Need to be able to get those things out in referenceable formats, and there are a lot of journals that touch on human spaceflight, all the aspects to human spaceflight, where it might not be a traditional journal you would want to write in, but we need a place where this whole broad community with different facets can go to find that information. So that might be something that this community moving forward, this next type of a workshop could start to do, is set that framework that people in these different bubbles can find the information quickly and easily.
Yeah, so I agree with strategic knowledge gaps. They tend to be written from a this is missing knowledge, as in and people infer that requires more data as opposed to talking to different people. And not to put Jim Green on the spot, but I know he's given some thought to the idea of a journal which is still peer reviewed, but is somewhere where you could be proposing things which are kind of are less pure science and more of relevance to the human exploration community.
Yeah, several years ago we put a GSA special paper together that was just called Planetary Analogs. And it was me and my colleague Brent Gary, and we had this idea for these types of papers that didn't fit science. They weren't something we could put in a science journal, because we talked to a lot of the editors and they said, no, that won't fit. So we had this idea, we put out a call at GSA, and we had so much interest in putting papers in there I forget what we received, something like 70 or 80 suggested papers. We ended up with just about 50 that got published. So the things are there. People have these on their desks. They have all this information. They just need to know how to get it someplace that somebody they don't even talk to can find it very easily.
No, good, very good point. Probably one more, then we'll move on. Yep.
This is Leslie Alexander, NASA Marshall Space Flight Center. To piggyback on the comment from the Arizona State young lady on the other side of the room earlier, the NASA technology roadmaps have technology areas such as TA7, which I was a part of, which is Human Exploration Destination Systems. And there's also a couple other areas which are encompass sensors and things like that. And there's an attempt to identify what's needed at the destination site to do analysis or to support the crew activities. Hopefully this group had a chance to provide comments back during the public comment period. The roadmaps have been delivered for this round, but we need to get feedback from this group as to what's needed, what types of sensors, and what's available currently, and does it meet the requirements? Does it meet the needs for what you guys need in the future?
Okay, thank you. Right, I'm going to move on. So we would like, at the very beginning, we said we would like feedback on this workshop. So what should be, well, this is kind of meant to be doing that. Well, I have the questions here as backup. We can go through at the end and double check. So what should be kept more or less intact? What should be changed? What should be added? What should be removed? What was missed? We sort of covered. And then, are the current EC criteria adequate, realistic? Thoughts on the rubric and comments on the requested feedback. So I'd like to, throw that out about, I've heard positive things about the workshop, but people will always have ideas on how to make them better.
I think the rubric was a very useful tool for us in helping to analyze and evaluate the site. So we had our little score sheets here. But for future instantiations of this meeting, a lot of times the presentation would be made and the rubric would be flashed on the screen very briefly and say, okay, you can come back and look at this later. I'm not going to take my time in the presentation for this. But that was oftentimes what we were using to a large degree in making our evaluation. And so we're turning in our evaluations at the end of the day without actually having had a real good chance to go through the rubric scores. So in the future, perhaps we could change that organization a little bit.
Okay.
Brandy Horgan, Purdue University. So having been involved in the Mars 2020 landing site selection process where we first started thinking about rubrics like this, they can be really challenging to fill out if you haven't filled out a lot of them before. It's kind of this catch-22. I know this one in particular, even though I've filled out so many, I still had a hard time filling it out for my site. And I think part of the problem is it's really hard to write a rubric that's based on specific observables that you can say yes or no to. So I think I almost don't want to say add more to the rubric because that would make it more difficult to fill out. But I feel like we need to think about what are specific threshold criteria that are based on observable quantities that we can use to evaluate these sites in that same kind of manner. And I think that would really help.
Behind you.
Yeah, a very similar kind of remark on the rubrics. One idea that occurred to me, again, the same kind of thing. A lot of the people, when they got up and gave their presentation, they're like, oh, I don't know what to fill out here. I don't have enough knowledge on this or that. Maybe one improvement you could do instead of just having a pure, yes or no, would maybe be to have like a set of questions, the same kind of criteria, but like on a sort of a sliding scale almost, like how likely do you think this is? And you could say, like from 1 to 5, like very unlikely, sort of likely to very likely. And then maybe that would also give a quantitative kind of aspect to it. So, where you had the thing, it said add up how many things you think say yes or no, and then there would be a number at the end. This way, maybe you could also include, how confident the person is that that particular feature is there.
One thing I noticed since I'm coming into this community, this is my first workshop in any of this, the supplemental material document for putting together the EZ had a lot of references. It referred to the Evolvable Mars campaign. And there were a lot of numbers that weren't necessarily complete in there, but I was not able in sufficient time to locate any of the documents that those numbers came from. So at least references to the larger format that this community is aware of, so that people that are just joining the conversation can actually have the background of what are we looking at, what capabilities are we talking about, instead of just a few-page supplemental material document that makes sense to everyone who's been involved in the conversation up to this point, but doesn't quite make sense to those of us that are just joining.
Okay.
Jojo Michalski, PSI, back here. Oh, hello. To your left. Azimuth 27, yeah, there you go. Yeah, just a few thoughts. I think, for one, I really appreciate all the effort that went into making this. So, I mean, at the end, we'll have a round of applause for that, but that's really a substantial amount of planning, and it was helpful for us to think specifically. It sort of forces each person, each presenter, each co-author to think specifically about the different problems. We end up, at the expense of trying to be quantitative and specific, we maybe end up judging things outside of our realm of expertise, and then having sort of, in other words, what I'm trying to say is I think a bigger picture approach may also have value. So while the rubrics are useful, when I look at a rubric on the screen, I don't get much from it, and I also don't know whether I trust the judgment of each sort of score, because personally I don't have the skills to judge the ISRU sort of things, for example. So I think it's a little bit weird that we're thinking about ranking sites and eliminating things and that sort of stuff to some extent. It should really be more about big picture. Hey, are we interested in high latitude? Are we interested in low latitude? What are the realities of each? Are we interested in minerals, or do we really need ice? Is this driven by science or not? Like, those are kind of the level of questions we're at right now. So my only feedback on the specifics would be it's a little bit too specific.
Okay. And to be clear, the goal of this workshop wasn't to exclude sites. It was to promote an initial discussion.
Yeah, and you did say that. I'm sorry, but it's our natural sort of tendency when we start ranking things, we get very competitive.
Hi, Steve Clifford, LPI. I think there were two things about this workshop that I think might have improved it, and one of them is grouping the landing sites into the same sessions that were located in a similar area. For example, our Valles Marineris discussion in the first session included at least one talk that was far outside the Valles Marineris area, and there were other talks that dealt with the general region of Valles Marineris that were scheduled later in the meeting, Pascal Lee's talk, for example. So I think it would benefit the discussion if you had sites that had many similar characteristics, especially geographic, being discussed in a single session. I think another thing that would be useful is to have a panel of people who were looking specifically at what kind of compliance there was between various issues on the rubric, whether it's identified H2O reservoirs, whether it's issues about trafficability or surface properties or whatever, and have that panel present at the end of the day a discussion of what they thought the pluses and minuses were of each one of these proposals, because I think it'd provide excellent guidance for the people who have made the proposals as to where they need to strengthen their arguments, or whether there's a fatal flaw in their suggestion that means that they need to look somewhere else.
So what I'll say to that is, actually, we did try, and there is a huge dispersion. We did try and do geographic where we could. Regard to your second point, it's a very good point. To do that for something where we've got 45 EZs, then that's going to double the length of the meeting. Do you know what I mean? That will significantly expand, which is fine if people are okay with that, but as this was the first one. But to do that, it would also require people to get in their presentations, 1 or 2 weeks ahead of the workshop, in order to give people time to analyze those presentations, in order to be prepared to have a useful part of the panel discussion. But I take your point.
Okay, the thing I was thinking about is that if you just had 5 people who were specialized in different areas of the rubric, and who took it upon themselves to read those abstracts that were being presented that day and listen to the talks, that it would at least provide a better sense of feedback and guidance out of that day's session than I think people get, for example, just from the minor amount of discussion that we have at the end of the session.
Okay.
Paul Vance Hunter, Michigan Tech University. I wanted to comment a little bit on the rubric and the process. We use extensive rubrics in teaching. And one of the problems that we have by using rubrics is that people always come at the same rubric with different backgrounds. And that means that even though you have a rubric, the same site could get vastly different answers from different people. So one of the things we do in education is we usually have a norming exercise, which is intended to train all the participants in, sort of saying, okay, when you see something like this, this is a 3. But if you see that qualifies as a 4. So you really set everybody to the same standard, if you will, and that makes the rubrics and the results of those much more comparable. Whereas if you have people from different backgrounds without any similar reference point, you get completely different answers, even though they all read the same thing. So maybe for future workshops, it might be good to have one example to say, this is an example site. This is how this scores. So if you see this would qualify. I think that might help for future workshops.
Okay.
I'm also going to say something about the rubrics. First of all, in defense of this meeting organized the way it was, it does feel uncomfortable when you get thrown into the deep end of the pool and you're angry that no one gave you the water wings. And that's kind of where we are. In planetary robotic missions, we've gone through a series of workshops to select landing sites. And that community of people may be comfortable with using rubrics. And I've been through those, and I'm still uncomfortable with those. But it's just the state of where we are. We're just kind of toddlers in doing this. If we don't make a serious commitment to say, we're going to Mars, and we know where we're going to Mars, this is a la what Jim had to say yesterday, then it's harder to bring along people outside of our community, such as Congress. So I completely endorse what we have done here because we had to do it. Now, how can we do this differently so that we feel better going forward? I agree with everything everyone has said about the rubrics in that the advocate cannot fill in all the green dots and say this is a great place. What we do as a community is the same thing we do when we read each other's proposals and manuscripts. We have a set of criteria that tell us accept or reject, and that we as a community fill in the rubric, not the guy giving the presentation. And if that person, say it's me and it's the site I want to go to, if I haven't made the case, same thing when I propose something, if I haven't made the case, I don't get the money. So I think that what we can do better next time is a combination of what Steve said and what Paul said, just a little bit of advance warning about how to read and rank a rubric. And then I do agree with you, it would take too long to have the meeting with us filling out with a panel of experts and asking questions and redirects. But what we can do is hand out, you people who are coming to this meeting, here are 6 sites. You people, here are another 6 sites. And we make meta panels, just like we do in a NASA review. And then we put together everything that we have found, and we come up with a set of rubrics that the whole community can vet.
Just to follow up on both of those comments, Brandy Horgan, Purdue University, I would suggest that something to think about with these reference sites moving forward is to use those as possible examples of filling out a rubric like that as an example to give to people at meetings like this. You can be like, well, this site, we think it has these characteristics. Here's an example of what that looks like.
But you've then still got the issue of the logistics during, say, the next workshop of, is it feasible to ask you either have to give the audience enough time to give the speakers enough time to describe the easy to the level where the audience can make a good go at filling out the rubric for them, or you have to ask the presenters to get that level of information out ahead of time and hope that everyone who's coming spends the time it takes to essentially look at either have more detailed abstracts or something like that ahead of time.
Yes, that you just said the magic thing. I think that there are people who love their landing site enough, they'll write a 6-page abstract, or at least I would. Okay. And so if you don't want to write the 6-page abstract, you don't get to present your site, but give the detailed abstract.
Yeah, that's really good point. Yeah. They're everywhere.
Nope.
Hi,
Pan copied my answer, so I'm going to pass my mic.
Okay. Hi, I have a mic already. I'm over here. Nikki Uichilo. Yeah, I agree with what everybody said, and I think that for the I know that the goal at the end of this workshop is to maybe make bigger teams that are more inclusive of a bunch of different communities. And I think, though, for a preliminary workshop like this, before you get to that bigger team portion with more people who have expertise in different fields, it would be good to maybe, I kind of want to segregate, but people can present sites based on their expertise, and then everybody can look at those sites like, okay, these are the ones that are good for geology, these are the ones that are good for biology, these are the ones that are good for ISRU and for robotics, and then we can find sites that overlap instead of having groups of people that don't really know certain aspects that we're looking for. So you'd have people present sites that are best for what they know, and then see which sites kind of have majority of those things.
So, Brett Drake, Aerospace Corporation. So what I'm struggling with through this conversation is we have a very complex process here and a lot of competing and interrelated issues that we're trying to get our arms around. There are ways to go through this from a decision theory perspective that could be useful if we maybe it begs for more of an analysis group type of an approach, because what we're struggling with is what is goodness. You know, what is goodness from a habitability perspective? What is a goodness from a resource perspective? And we've gone through decision processes before where analytical hierarchy type processes where you take site A versus site B and you compare the goodness between the two. And I think we're so early in the process that it's not necessarily picking a site, but we need to tease out what makes goodness. And it's through the dialogue at this early stage that I think is the most important thing. We've seen process before. We were trying to make decisions on launch vehicles, for instance, and we were ranking different concepts. And through the process, almost everybody was ranking it one way, and there was one outlier. And it was through the discussion that we had that one outlier described their concerns and their approach, and it completely changed the way the entire group thought. It was that dialogue that was important. So I'm thinking that maybe that should be the next steps that we have is we as a community from all these different competing issues need to go through a process where we tease out what makes goodness. And then when we have those goodness criteria better defined, we can go through a process like this to then start to rank and use these rubrics to measure the goodness of these various
I mean, to be fair, that's why we set up the working groups originally, like HSO, SAG, and ISWIG, to try and come up with what is goodness. Now, if you're saying we need to take that to another level, that's a valid point. But we did try and do that going into this, which is why when you look at the rubric, you know, you had threshold criteria, which in a way was our first attempt at defining goodness.
Well, and Brett, I'd just like to echo that. I mean, you were involved with developing those, so you know. But I mean, it's iterative. You know, we're getting feedback here. We'll go feed that into the process. You know, I think really the next step for the next workshop is really honing down these criteria and limiting it down. I mean, you know, obviously there's a big divide between hydrated minerals and sheet ice. You know, and so we need to kind of push that envelope as much as we comfortably can as a community, and then figure out, you know, and iterate to a solution. And I really think we'll get there. And you run the hazard of, with rubrics or whatever, that you will lose the forest for the trees. So there's a balancing act that has to be done as we go through this.
Yeah. So as one of the so Paul Niles, JSC, one of the co-authors of the rubric. Sorry. No, I mean. Basically, this discussion is kind of headed towards, my response to this is maybe we need to throw out the rubric because that's not really where we weren't headed in a ranking mode. We weren't headed in a we need to have a check mark here or not a check mark there. We kind of wanted to use it as a guide to sort of visualize what was, the goodness, and I think what Brett was saying. So, if the rubric kind of guides us towards needing to quantify and, rank things, then I think that's not doing the right thing.
Okay. There's what people at the back being very patient. All through.
Oh, okay. Thought you had a mic too. Jonathan Hill, Arizona State. Just to follow up on an earlier question and comment about feedback, I thought the paper feedback forms that people were filling out every day would be very useful. Are the presenters going to have access to that feedback? Or is there going to be some mechanism to pass that back to us?
No, I think the intent would be yes.
Yes. The intent is yes. I'm not sure we quite know the exact mechanism yet.
Well, and similarly, these presentations have essentially all gone out Ustream, so we have to figure out a way to make them available to everybody too. So, those are all pieces that we have to get in gear
here. Okay, Laura Kerber, JPL. I was thinking about what everyone was saying, and as far as the rubric, because as a scientist, having the rubric and having to fill it out was a really good exercise for me to say, okay, this group met. What did they come up with? Oh, that's very interesting. That gets me thinking. I know Mars really well. I know where to find all these things that they discussed in the rubric in an exploration zone. But from the perspective of saying, we're just starting out, we're toddlers, this kind of stuff, I felt like it would be useful to say, have some presentations, maybe like a day of science where you're saying, what do scientists think are important? Some of it's listed on the rubric, and say, okay, Mars has ice in all of these high latitudes. And then geologists are interested in minerals, and they're interested in valley networks, and why are they interested in that stuff, and here's how it's all arranged on the surface. And then to have the ISRU people say, we like a resource that we can come right up to, or that's on a slope that's less than this many degrees, like a whole day of ISRU. Here's a bunch of technologies that we've developed and that kind of stuff. Maybe a day for engineering, here's the kind of concerns that we come up with, so that each one of us can have a more global idea of what makes a good exploration zone. And then, and so that not that each person would write a 6-page document about why their particular area is good, but that all of us together as a community can have a better vantage point from which to judge what's good. We are all sort of on the same page as to what everyone else is looking for.
Okay. Pascal?
Yep. So Pascal Lee, NASA Ames. And actually, come to think of it, I might get in trouble, so let's say Pascal Lee, Mars Institute. I just want to point out that, as far as I'm concerned, this workshop really served what I understood its purpose to be, which is to, first of all, create this community and bring it together and have a starting point that, might be a little too far ahead or too, or too shy still, but whatever, it was still very useful the way it is. And in some sense, the challenge that I feel we face with picking a landing site on Mars is that what goes into the choice of a landing site depends on, of course, what you want to do, but also on what you can do. And the part where we're talking about what we can do, what technology will allow us to do, how mature ISRU will end up being and when, what landing capability you'll actually have, are things that we, in reality, are really left to guess about right now. When you're planning or picking a landing site for a rover mission in a few years from now, the problem is much more constrained. You know what the rover can do. You have specific science questions, and you don't have issues like will you be able to support the rover with local resources other than sunlight. But in this case, we're faced with especially because we want to pick a site that's going to be of value, presumably for the long term as well, not just something that's going to be, successful for the first mission. So there has to therefore be an iterative process where we really at some point nail the technology we feel we will have for this campaign to Mars, for this journey to Mars, what we can count on. And the way I envision this is this map already had some grayed out areas. There were altitudes where we cannot land. There were latitudes where we should have, that we should avoid, And I'm envisioning that over time, this map will essentially have more and more gray areas, where it doesn't mean that the science of those sites is not good. It just means that, given what we plan to have in architectures and what's going to be possible technologically, and by when, we will just have places that we cannot land at. Doesn't mean we can't access them once we're on Mars, just that we can't land there. And that will rule out where we can have a base, really, if we can't land there.
Okay, so agreed. And that's kind of
so a running map like this would be a cool thing with a website and a resource.
Okay, we'll have two more. You've been in the blue shirt, and then in the other blue shirt.
Austin Nicholas, JPL. I think the thing that I heard most at this workshop was, I'm not an expert in this, but, and I think it would have been really cool to have some of those experts open up with presentations, like for instance on ISRU, on mining, on engineering, not just presenting this landing site, this landing site, this landing site, this landing site, but sort of express some of the, like what other people have been saying about technology and engineering, things that might go into what makes a better landing site so that the landing sites can improve on those qualities going forward.
So what I would challenge you to do then to help us get there is we actually tried to do that. We actually had those briefings at the beginning. Now I think we're ready for the next level, which I think is what you're referring to. And I would suggest, send us an email to the email account that we have here. Tell us what you think would fit in there. I would invite everybody to do that, so that the next time we do this, we can drill down further. I'm a big believer in throwing the ball and back in your lap to help us find an aggregate solution, because I think you're onto a very key point. But help us figure out how to do that, because this is really a team thing here.
Laurent Sibyl, Kennedy Space Center, and ISRU. And one thing I wanted to say is that for us, the community at ISRU, mining and civil engineering, comes at this in wide open eyes, because we've never been involved in a process like this. So we look to the science community to actually educate us on how this is done for you. Now, in terms of helping moving the dialogue forward after we all leave today, I think the idea of having us maybe offer some feedback on the exploration zone that the authors care about, and say, here is what we see from our point of view in your exploration zone, and maybe that helps continue that dialogue, and maybe help what Brett was suggesting in terms of an analysis group that is useful.
I actually wanted to follow up both on what Laurent said and also what Austin was saying. Charles Wetzel at NASA JPL. This group actually, I think you guys did a great job coming in cold. And as we said, there's a lot of context here. The science side has been through some drill like this before. John Grant got up there and started doing his usual landing site routine almost without introduction on the first day. And Vicky's idea of Victoria's idea of the IceMag, getting a group like that going. When the science community does these landing site workshops, they don't do it out of context with all the back channel communication and community building that's happened in MEPAG over the years. Even within planetary science, MEPAG is kind of the grandfather of XAG and OPAG and all the other AGs, right? I think using MEPAG, or those of us that have been involved in MEPAG, to help get IceMag up and going, and having one of those groups where the experts there can get together and kind of post-process what's happened here, get ready for the next workshop where you come back together again, reaching across the aisle between the science communities and the ICE communities would be a really strong thing. But I think the IceMag is going to be the key to that.
Okay, thank you. Right, we're going to take a break. There'll be more time for discussion. If we could meet back here at 20 to 10, that would be great.